This is the CS2316 project presented by Yanni Kassaridis.
And Jayesh Agarwal.
Our project is examining the motor vehicle collisions in New York City. Some of our data sets include a large CSV from the City of New York website, and each entry is a recording of a collision that occurred in New York City between the dates of July 1st, 2012 and March 4th, 2023. There is approximately 1.9 million rows, but after cleaning it, and for the purpose of this phase 3 presentation, we have shortened it down to about 1.3 million. That's what we use in all our visualizations and our insights. Do you have anything to say?
So for data collection and cleaning, we looked up on the government websites and on various websites. We got our data sets from there, our CSV file, our APIs, and our HTML. For cleaning our data sets, we used Beautiful Soup, we used Pandas, Request, regex, and JSON.
That's right. And a lot of our data cleaning revolved around really shortening and deleting a lot of rows and columns that were irrelevant to certain visualizations, because we were dealing with such large data frames that we had to, in our Jupyter Notebook file, you'll see, we just created a cell for creating all of our data frames, and then we reference those in each of our insights and our visualizations. And by doing that, we made it possible for us just to run that one cell, and it would take maybe 3 minutes, and then we would be able to instantly run any insight or visualization. So you'll see in the Jupyter. So this is snippets of our data cleaning. As you can see, it's just like as we had said, it's a lot of renaming so that way we can merge data frames together. A lot of going through, iterating through columns in the data frame to get counts and sums of certain figures, such as the count of collisions per zip code, or the quantity of fatalities as a result of collisions in a certain zip code, and etc.
So for our Insight 1, we used interactive choropleth map to mark number of collisions per zip code, and by moving our mouse to every zip code, we can see how many collisions have been there, and we integrated the Bokeh model to have interactive choropleth map in our Insight.
That's right. And the way that this works is by we first have to take our data frame and we have to convert it to a JSON dictionary, and then we have to run that through a method in Bokeh called GeoJSON data source, and that makes it able to be read by Bokeh. And this is after, of course, merging our original data frames with a shapefile that we found on this City of New York website also. So this is what helped us create geographic models.
So for Insight 2, we calculated the number of collisions by type of vehicle, and we found the top 10 types of vehicle which were involved in the collision. And as you can see, we have SUV on the number 1 spot, with sedan following it, and the whole list is there.
Right. And so this insight lets us observe that the primary cars that get into collisions in New York City are usually civilian-driven vehicles, whereas commercial vehicles don't get in as many accidents. However, large commercial vehicles do get in more accidents than pickup trucks, which I believe is due to New York being so urbanized that not many people have pickup trucks. And additionally, commercial vehicles, they're driven by highly trained professionals. They're everywhere all the time, and it's an accident-prone situation.
So for our Insight 3, we tried to find out what time is when the most number of collisions take place, and we were quite surprised to see that most number of collisions take place during the midday from 11 a.m. to 4 p.m.
Right? We believe this is because this occurs during the main rush hour periods when people try to leave work early and to get back home. For our Insight 4, we try to draw relations between fatalities and various demographics by zip code. And what we found is that though there is very little correlation amongst any demographic and fatalities in a collision, our trend lines do indicate that there's a slight inverse relation between uh, zip codes that receive lots of public assistance and a slightly positive uh, correlation between uh, zip codes that have a higher percentage of whites.
For our Insight 5, we tried to gather data about the leading causes of death in New York City, and we compared it with the deaths caused by motor vehicle collisions, and we were quite surprised to see that it is pretty less as compared to other leading causes of deaths.
In visualization 1, this is a more in-depth perspective from Insight 1. So rather than showing the number of collisions per zip code, visualization 1 actually shows the ratio between fatal incidents and non-fatal incidents. So here you can see the hot spots of where the most dangerous accidents occur relative to the number of accidents that occur.
And as you move through the choropleth map, you can see that it is very interactive. And as you move your mouse, you can go to any zip code and you can see number of collisions and number of fatalities in that zip code.
In visualization 2, it's a visualization of our previous Insight 3, I believe, just to give a visual perspective on the immensity of other leading causes of death as compared to motor vehicle collisions.
Figure it out that SUVs were responsible for most number of crashes, and as I mentioned before, we were quite surprised to see that largest number of crashes took place during 11 a.m. and 4 p.m.
And from our data, we analyzed that in zip codes where percent received public assistance was high, the fatality of collisions was much lower. And here's an example of our chloropleths to demonstrate their interactivity. That is a hover tool as offered by Bokeh. And here, in greater depth, visualization 1.